Good morning, everybody. Welcome to another exciting morning of Chemistry 1211 with your host, me, Dr. White. And today we'll be doing some fun things. At least I think it's fun. I'm a chemist. Remember that. I'm biased. But anyways, here's the game plan. First of all, I'll go through problem set chapter 10, and there was some confusion on that, and part of it's my problem, bad Dr. White. And then afterward, I'll do something that I think will help you out. Then we'll talk about today's lab. And then after that, what we'll be doing is I'm going to pick 5 people beginning of the alphabet. I mentioned it yesterday, and we'll go to the breakout room and just talk. And I'll get to know you, and you'll get to know me. The rest of you can run away, and if you have any questions, and come back after about 10 minutes or 15, and then uh, if you have questions, I'll stick around. But like I said, we'll do problem set, some good stuff to help you out. I'll do the breakout room with 5 people. Then, if you have questions, come back. If you're not one of those 5 people, and I'll help you out. And I should get you out before midnight. All right, let's get going. All right. And I just realized I need something else up here. All right. Let me check because I've been maneuvering around. Thumbs up, people. Does everybody see part one, chapter 10 on your screen? Thank you, thumbs up, people. All right. Now, question is, which ions will the following elements form? How do you do that? Well, you take and say, all right, I have sodium. And you look how many electrons and protons. Where do you get that number? You get that from the periodic table. And notice the atomic number 11 tells you how many protons and how many protons and electrons an element has. Now, sodium has 11 electrons, 11 protons, and it wants to go to the nearest, have the same number of electrons as the nearest noble gas. And if we look at the periodic table, we see sodium at 11, numerically the nearest one is neon at 10. And therefore, it wants to have the same number of electrons as neon 10, but the number of protons doesn't change. Now, each electron has a -1 charge. Each proton has a +1. And do the math. -1 times 10 is a -10. 11 times +1 plus 11, add it up, get +1. How do you show the ion? Chemical symbol, then to the right, superscript. When the number is 1, you just do a plus. If it's negative, a minus. If not, you use number and the charge. Now, I should have taken C out of there because it can go either way. And with that, carbon usually doesn't form ions anyways. So let's do another one, nitrogen. And I'm going to let you, if you haven't done it, what ion will nitrogen form? By the way, it's your turn. I should get a hat. I think I'm having a bad hair day. Actually, I shouldn't complain. I got hair. The reason I'm laughing, my best friend, by the time he was 30, early 30s, he was about this whole area up here, bald. I used to kid him. Now he's kidding me. Oh, you're getting just like me. I no, I got more hair than you do now. All right, anybody need more time? All right, let's do this. Question is 2 or 3 points, depending on my mood when I write the test. If I put it on test, hints. Uh, Nitrogen. How many electrons and protons? 7. What's the nearest noble gas? Well, neon is 7 away. That's 7 away, 3 away. And helium is a lot more, 5 away. And argon is way more. So what's the closest numerically? Neon. So what does that mean? It means I got to take the pen cap off my pen, get my whiteboard all ready. And we have neon, nitrogen. I got neon on the brain tonight or today. All right, has 7 electrons, 7 protons. And can you see anything, my whiteboard? Ah. All right, I see a question. All right, somebody beat me to it. I'm gonna let you guys do the class this morning. No, I won't. But anyways, it wants to go to nitrogen with 10 electrons, but it will still have 7 protons, and that's 10. Each electron is a -1. Each proton is a +1. Do the math. And how do you write that ion? Chemical symbol. And you can do -3, which is the old way that Dr. White likes to do, or you could have just as easily done it this way, which is the newer way. And that's how you do it. Oh, let's do one more. These are fun. And, oh, why don't you do calcium? Don't look at it. Oh, you looked, you peeked. All right, what ion will calcium form? And there's a periodic table. I think somebody's already got the answer. All right, I think everybody's done. Question is, what ion will calcium form? Now, calcium is at 20 right here, and That means the atomic number is 20. Calcium has 20 electrons, 20 protons. What's the nearest noble gas? And argon is 2 away. Krypton is a lot more than 2 away. So it's the closest argon. And argon has how many electrons? The atomic number tells you that, 18. So what does that mean? Time to switch to my whiteboard. For calcium, you have 20 electrons, 20 protons. It wants to go to 18 electrons, but the protons never change. How do we get that? Because that's the same number of electrons as the nearest noble gas. Well, each electron is a -1. Each proton is a +1. Do the math, -18 plus 20, add them together, you get a +2. And the question was, what ion does calcium form? And the answer is +2, which you could write this way, like Dr. White likes to, but you could also write it this way, which is the newer way, which I don't like. But either way is correct on the test. Now, important thing, remember, once you know one element in a family, you know them all. So if I know calcium is a +2, what ion does magnesium form? Time's up, +2. Now, sodium forms a +1. What ion does lithium form? +1. Same thing with potassium. If we come over here, nitrogen forms a -3. What does phosphorus form? -3. Isn't that amazing? Yes, it is. Thank you. You're welcome. All right, let's move on in the problem set. Now, the next question is, write the empirical formula, which means the simplest formula of the molecules formed by the following ions. How do we do that? Remember, oh, it's even written on the paper. Remember, I wonder who's that nice person who did that. Remember, all molecules have a net zero charge. You can't change the charge, but you can change how many of them. And if we look at sodium bromide, Na plus, Br minus, to get to 0, one of each. If we look at sodium and sodium cation, oxygen minus 2 anion, let's go to my whiteboard. And the question is, what is the empirical formula for a molecule formed from these ions? This is a +1. This is a -2. It has to add up to 0. You cannot change the charges, but you can change how many. Well, if this is a -2, I need this to be a +2. How do I do that? Oh, I put a 2 there. And therefore, how do I write that? There's 2 sodium and 1 oxygen. And that's how you do it. And why don't you try this one, then I'll do it. What is the empirical formula for a molecule made up of magnesium plus 2 cations and nitrate -1 polyatomic ions? By the way, in case you were wondering, if we were face-to-face at COD in the lab, I would be doing this the first just like I'm doing now, first half hour, 45 minutes, going through a problem set and helping you with stuff. And then we do the lab and you still get out early. Dr. White always helps the students get out early. All right, let's do it. Now, well, I'll give you another 30 seconds, 22.5 seconds, go. I'd say the clock is ticking, but I have an electronic watch I'm looking at. I don't think it ticks anymore. It never did. With my hearing, I wouldn't hear it anyways. All right, time's up. Put down your pen and pencil, hand in your paper. No. All right. Remember, all molecules have a net zero charge. This is a +2. This is a -1. It always equals 0. No exceptions. You can't change the charge, but you can change how many of that either that ion is in the molecule. So to get this to 0, I need 2 of them. How do I show that? Magnesium. Now, this is a polyatomic ion. How do I show more than one? Bracket, NO3, close bracket, and to the right, subscript 2. And that's how you do it. Oh, let's do another one of these. I think you could use to practice. What would be the molecule that you would make right, or the empirical formula, calcium +2, hydroxide -1. All right, let's do that. I was just looking up something and I was right. Remember, Dr. White's an organic chemist, and this is inorganic stuff, but I know my stuff. All right. Remember, all molecules have a net zero charge. And therefore, to get this to add up to 0, you need 2 of these. How do I show that? 1 calcium. I have 2 hydroxides, polyatomic ion. And that's that. By the way, this is the major component in the product called lime. And that's the material used in cement, calcium hydroxide. All right, and that's how you do ions. Now, next question is draw the Lewis structure for the following and circle all double and triple bonds. Well, how do you do that? Lewis structure, you use valence electrons. You should know valence electrons are the outermost electrons of an atom. They're the most important because those are the ones always involved in a chemical bond, which is the coolest part of chemistry, making chemical bonds, meaning making new stuff. So let's do a couple, and let's go to our whiteboard. And if let's do one a little different from the problem set, let's do chlorine. Now, how do you do that? You look up that chlorine has 7 valence electrons. How do I do that? Well, you go back to your periodic table and you look at the top, and here's chlorine, and the number, either the Roman numeral VII or the numeric 7, which I politely gave you, because I found out a couple of years ago a lot of my students didn't know Roman numerals. We learned that in, I think, second or third grade. Boy, that was a long time ago in a galaxy far, far away. But anyways, chlorine, 7 valence electrons. So what do? I see a question. Okay. I have a chlorine with 7 valence electrons. I have another chlorine with 7 valence electrons. They say, you've got one, I've got one, let's share. And this forms a covalent bond. And you should know the covalent bonds. Let me put it up here or on here right now. And you should know single bond has 1 pair of electrons. And remember, pair means 2. Double bond, 2 pair. Triple bond, 3 pair. Everybody, you don't have to turn on your mic. All together with Dr. White, and I do this in a classroom or a lab. Everybody, nice and loud. What's the first type of covalent bond? Yeah, single. What's the second type? Come on, everybody. Double. And the third type, yeah, triple bond. So there's single, double, and triple bond. And you should know single bond, 1 pair of electrons, double bond, 2 pair, triple bond, 3 pair. Now, why don't you try drawing the Lewis structure for iodine, I2? And it looks like everybody's done, so I'm gonna go do it. It has 7 valence electrons, and therefore each iodine has 1 unpaired electron, and one iodine says to the other, hey, I've got an unpaired, you've got an unpaired, let's share, and that's it. Now let's do oxygen. Oxygen has 6 valence electrons. Let's find out if Dr. White could be lying to you or not. How do you find out? You look at the periodic table, go to the top, and the number is 6. I was telling you the truth. I always do. And how do we do this? We say this oxygen, and you don't have to write these like this the way I'm doing it, but I'm showing you how it works out. This oxygen has 2 unpaired electrons. This oxygen has 2 unpaired electrons. And they say to each other, let's share our unpaired electrons. And the non-bonding electrons are still there. And 2 pair, what kind of bond is between the oxygen atoms? Time's up, 2 pair of electrons, it's a double bond. Now, let me make room over here. Why don't you try nitrogen gas? And this has 5 valence electrons. How do you know that? You go to the periodic table. And also tell me, or in your mind, think about what kind of bond is in between the 2 nitrogen atoms. And when you're done, give me a thumbs up. Well, I think everybody's done, so let me do this. What do you do? Well, I like to do this. Here's the Lewis structure for 1 nitrogen. Here's the other one. And you can do this in your head too. And notice each one has 1, 2, 3 unpaired electrons. 1, 2, 3. And one nitrogen says to the other, hey, let's share our unpaired electrons. The non-bonding electrons are still there. Those are the ones I just drew in. They're not involved in any bonding. And 3 and 3 make 3 pair. And what kind of bond is that? It's a triple bond. Why? Because there are 3 pair of electrons being shared. Now, let's look at the following with a polyatomic ion. And the question is, draw the Lewis structure for sodium hydroxide. Well, the first thing you should know is any alkali metal, any alkaline earth metal, meaning any element except hydrogen in the first column, any element in the second column, always forms cations. They are never in a covalent bond. And we already figured out sodium, all the alkali metals, and you should remember this, form a +1 cation. Now, oxygen has 6 valence electrons, hydrogen has 1 valence electron, which you can go and look in the periodic table. So I'll put this oxygen with 6, and hydrogen has 1, says let's share, and it does. Remember the octet rule. I forgot to mention up here, if you look here, each nitrogen has 8 electrons around it when it's in a stable molecule. The exception is hydrogen, its octet is 2. Well, this oxygen doesn't have 8, it has 7. But wait, where did the electron that the sodium has, because sodium has 1 valence electron, go? It went over to the oxygen, and this forms this anion, because now has an extra electron. And that's how you do it. And now it's your turn. Sodium has 1 valence electron, carbon has 4 valence electrons, and nitrogen has 5 valence electrons. Carbon's going to be in the center, sort of. And if you happen to notice this morning, I'm up to date on my YouTube videos. Yay, Dr. White. All right, anybody need more time? Well, I guess not, so let's do it. Now, sodium is an alkali metal and always forms a +1 cation. Carbon has 4 valence electrons. Nitrogen has 5. And notice nitrogen has 3 unpaired. Carbon has more than 3. So nitrogen says to the carbon, hey, let's share electrons. I've got 3, you got 3. And they do. The non-bonding electrons on the nitrogen are still there. Notice carbon doesn't have an octet. But what happened to the electron here? It goes over to carbon. This now has an extra electron, so it has a negative charge, and that's how you do it. Now, one of the things I should have done is problem 4, take out. We're not going to do that this semester. And I could show you how to do it, but I didn't talk about it in the lecture on purpose. I forgot to take it out of the problem set. All right, now I think there was another chapter 10. We've already done this. I think we've already this is a repeat of what we did in chapter 9. So Somehow my recording stopped. Well, I apologize. Uh, but anyways, I must have hit it accidentally. Does that once in a while. If you haven't figured out why. All right, any questions? Going once, twice? Yep, it's recording now. I just turned it back on. Can you see if it's recording from your end? Anybody answer? All right, if you, every once in a while, you look and if you see it's not recording, please let me know, because I'm really deep into talking and lecturing and I miss that it's turned off. And the answer is, all right, one of your colleagues asked to see the last one. And here we have sodium cation. Carbon has 4 valence electrons. Nitrogen has 5. The nitrogen says, I've got 3 unpaired electrons. You've got, let's share a do to form a triple bond. And then the electron from here goes over to the unpaired electron on carbon to form a pair. And that makes it a negative charge. So there's a ionic bond between the sodium, and this is called the cyanide, anion, and a triple bond between the carbon and nitrogen. And that's how you do it. All right, let's do something useful. I see a question.
I'm sorry, I have a question.
Why should you be sorry? Questions are allowed. Don't.
I keep forgetting.
Well, I'll get you guys trained yet. You know, it's sad. So many faculty don't like questions that students like you and others feel they have to say they're sorry for asking a question. Never, ever say you're sorry for asking a question in my class.
Okay, well, thank you. The question that I have is on drawing the Lewis structure when we've got an alkali and an alkaline earth metal. The last example I think you used was it NaOH?
Yeah.
Would there ever be an example where it's like Na2OH?
Not with a Lewis structure. Oops, I did lose something.
Okay.
I could, but that's beyond the scope of this class, honestly.
Okay.
I could write a test easily that the highest score would be 25 or less, which only shows you I wrote a test that wasn't fair.
Okay.
Which I don't do.
Okay.
And when I was in grad school, we had to take these special tests called the cumulative exams. And by the end of your 4th year in grad school, you had to pass 4 of them. There were 2 grades, pass, fail. 50%, 50 points was the cutoff. And they could ask you anything on anything. It was that dealt with your area, in my case, organic chemistry. And I remember the first one, I already had 3. In my 4th year, I needed 1 more. The first time it was given, I think it was given 3 or 4 times a year, maybe 5. I forgot right now, it's a long time ago, but not many. And I got the second highest score on that test. There are about 50 grad students in organic who took it. My score was 52. The highest score was 54. The rest of the people flunked. Those were not fun tests. But anyways, let's do something fun. All right. All right, question is, say 5 or 6 or 7 points. how many molecules water are 7.776 moles of water. Now, to help you out, I'm going to let you try this first. Remember, 1 mole of an element equals Avogadro's number. Atoms of an element, 1 mole of a compound equals Avogadro's number, molecules of that compound. And this will be given to you in test number 2, important information. But why don't you try doing this, and then I'll do it. Don't forget to use your good buddy, your good friend, unit analysis. Oh, I snuck that in. And when you're done, give me a thumbs up, or, oh, let's try the polling again. I see people still ciphering, so that came from Beverly Hillbillies, Jethro. Now I'm doing super generation gap on all of you. When he used to do any kind of math, and he had like a 3rd grade education, even though he was in his in his 20s, he'd say, oh, I'm going to do some ciphering now, when he'd add things up. All right. Do the poll. And the answer is no, you shouldn't always round off. I'll explain why in a second. Let's try something new. Let's relaunch it. Well, I think everybody's just about done. So let me get to work. Now, as you've learned by now, when I read a problem, and you should do the same, it will help you. What are you trying to find? Molecules, water. What are you given? 7.776 moles of water. This is the only thing we have to work with, so I'm going to start with that. And then if there was some ratio I could use to convert it to my answer, the units of my answer, what units do I want? Well, we figured that out. It's molecules, water. And now it's time to use your good buddy, your good friend, and my good buddy and my good friend, unit analysis. Whatever we're trying to get to goes on top. Whatever units we're trying to get rid of go underneath. And where do I get these numbers? You look at important information. I used to make students memorize this because I had to memorize it when I was a student, but now I don't. 1 mole of a compound equals 6.02 times 10 to the 23rd Avogadro's number molecules of that compound. And now I can put in 1 mole is 6.02 times 10 to the 23rd. And before I pick up my calculator, remember anything divided by itself equals the number 1 because it cancels out. Moles of water divided by moles of water cancel out. What am I left with? Molecules. So now I can go to my spreadsheet. Let me open it up first. And put in plus 7.776 times Avogadro's number. Hit enter, and this is the number I get. Now, when we did the multiplication, 7.776 is 3 significant figures. Avogadro's number that I use and most chemists use, 7.776 is 4 significant figures, and Avogadro's number is 3. When you do a multiplication or division, your answer should have the same amount of significant figures as the number that has the fewest significant figures, and that would be 3. So I'll let you round that number off to 3 significant figures. And hopefully you're done. Keep the 4, keep the 6, keep the 8. Those are my 3. Use the 1 to round off. Is that 4 or less or 5 or higher? 4 or less. Drop everything. So the answer would be 4.68 times 10 to the 24th. And let me go back here, and then I'm going to answer a question. And why is this? Nope, I think I need a new tip on here. All right, now, got a question? All right, now the question is, should we always round off our answers to 3 decimal places? And the answer is no. You have to check the numbers, like here and here. Now, instead of this, what if I put 7.7, then whatever number you got here, which is not the same as I have on the paper, but you would have to round off to 2 significant figures, because now this would be 2 significant figures, and this is 3 significant figures. And when you do multiplication division, the number you get should have the same number of significant figures as the number that you multiply or divide that has the lowest. Remember, exact numbers, which 1 is, are not considered when you're determining significant figures. All right, I'm going to do something I normally don't do. We're going to go, instead of till 9:50 till 9:55 or thereabouts, and take our break. Come back. I'll still get you out early. So I want to do one more problem here before we do the lab, and that is the following. All right, and I should tell you important information I'll give you. Here are the atomic weights for hydrogen and oxygen to 3 significant figures, And one other thing I should point out, if you look at important information, 1 mole of an element equals the atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of a compound is the sum of all atomic weights. I'll read it again. 1 mole of an element equals the atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of the compound is the sum of all atomic weights in that compound. And that will be given to you in test number 2. So have fun. But the problem is when you're in share, you can't tell if you're recording. I just checked I am. Yep, I just checked myself. If I go out of share, I can tell if it's recording. And if you look at the syllabus, I believe we're right around on track and on time, which is a good thing. I'll give you another 30 seconds to finish up. Or I can do the following. Start another poll. Dr. White's getting addicted to these. All right, looks like just about everybody's done, so let's get to work. All right, first thing, what are you being asked to find? How many moles water? What are you given? 9.6 grams of water. And therefore, the only thing I have to start with is 9.6 grams of water. And if I could convert grams of water, what units do I want to get to? moles of water. And now I'll come over here, change the color pen, and I'll use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top. The units I'm trying to get rid of go underneath. Moles of water goes on top. Grams of water goes underneath. Where do I get these numbers? I look at important information in case you forgot. 1 mole of a compound equals its molecular weight in grams, and the molecular weight of a compound is the sum of all atomic weights in the compound. So now what I have to do is determine what's the molecular weight of water. Water is H2O. There are 2 hydrogens, 1 oxygen. Each hydrogen has an atomic weight of 101 to 3 significant figures. Each oxygen, there's only one, 16.0, 2.02, 16.0, add it up, and you get 18.02. Now, when you're adding, you have the same number of significant figures to the right of the decimal as the number that has the fewest. This has 2, this has 1. What's the lowest number? 1. So I keep the 0, use that to round off. It's 4 or less. So 1 mole of water is 18.0 grams. Now, before I pick up my calculator, I'll look and see do my units cancel out. And here I'll remind you anything divided by itself equals the number 1, cancels out. Grams divided by grams of water cancel out. I'm left with moles of water. Yay, I'm on the right track. And now I'll go to my calculator. And I get this number. Wow, that's a lot of 3s. Now, I've divided 9.6 by 18.0. 9.6, 2 significant figures, 18.03. So you round this off to 2 significant figures, because when you multiply and divide, your answer should have the same number of significant figures as the number that has the fewest. And here we have, keep the 5, keep the 3. Look at this 3, 4 or less. Yes, I drop it. So that'd be 5.3 times 10 to the minus 1. And that would be our answer. And someone just asked a very good question. What if you weren't in scientific notation and you wrote it like this? And a lot of you probably wouldn't put the 0 there. I would. These are the same numbers. And guess what? Dr. White knows how to convert from scientific to normal, numeric, and vice versa. So either way would be correct on my test. That's a good question. And if I look at the time, ooh, we went really far, but I wanted to get through this. What I'd say is, let's take a break, and I'll give you a whole extra minute today. Am I nice? Come back at 10:05. I'm going to go get some more water and stretch. I'll see you in about 5.5 minutes. 10:05, come back. We'll be out early today. I was just looking at the news and I'm glad I'm not living in Texas right now, especially what they went through and what they're going to go through. Sad. And that's my political commentary for today. All right, everybody, ring, ring, come on, back to class. Come on back. Ring, ring. All right, let's get started. Today's lab deals with balancing chemical equations. Dr. White believes that practice makes perfect. I do. And therefore, I'm going to have you practice doing balancing chemical equations. How? Make it worth 11 points. See how cruel I can be and mean? But it's for your benefit. Let's take a look at the lab real quick. And you'll see you can download this for this lab. You're to balance the chemical equations in the next 2 pages. Submit the balanced chemical equations to the assignment area Blackboard. Now, what I'd like to go through and review, which is good for your grade and also helps you learn this stuff, which is really what I'm trying to do, is let's go through some basics. And if you see on your screen, and I haven't asked, but thumbs up, people, do you see A plus B goes to C on your screen? Thank you. And you should know A and B are the reactants. Which Dr. White, coming from industry, chemical industry, also will sometimes call the starting materials. And C, and if there are more, are the product or products. And you should know that. Now, when you balance an equation, you should have the same number of atoms of each type on both sides of the arrow. And how do you do that? You can't change the formula, but you can change what's called the coefficient. Let's look at example. And here we have sulfur in this form plus fluorine is sulfur fluoride. Well, how do you do it? Well, I've got 8 sulfur here. How do I get, I only have 1. How do I get 8? I put an 8. You can't put an 8 there. Students like to do that, and it's always wrong. Well, now I have 8 sulfur and 8 sulfur, but on this side I have 6 fluorine. No, I have 6 times 8. I have 48 fluorine. How do I get 48 fluorine here? When this is fluorine gas is F2, divide this number by 2, and we get 24. And somebody beat me to it. And that's how you balance an equation. And let's have you try one. And why don't you balance this chemical equation? Give you another 10 seconds. All right, let's do this. How do you do this? Well, you have to have the same number of atoms on each side. I've got one zinc. I've got, one hydrogen, two hydrogens, and I've got two chlorine and one chlorine. Well, how do I change that? I put a 2 in front. Now I have two chlorine, two hydrogen. Those are spoken for. I have one zinc. I have one zinc. And it's balanced. And that's how you balance a chemical equation like that. Now, when you have something more complex, my advice to you is leave oxygen and hydrogen last. So here's one for you to try. You take ferric chloride, ammonium hydroxide, you make ferric hydroxide and ammonium chloride, and you have to balance it. So ready, set, go. And I would recommend you do hydrogen, oxygen last. Remember my advice to you is leave hydrogen, oxygen last. Those of you done early, please be patient. I try and give everybody time to finish. All right, I think everybody's done. Let's do this. And the question is, how do you balance this? And that should be a Fe. I've got one iron, one iron. That's good. And I like to go this way. And, ooh, I've got 3 chlorine. If I only have 1 here, how do I get 3? I put a 3 there. Now I have 3 chlorine, and I also have 3 nitrogen. Well, I only have 1 here. How do I get 3? I'll put a 3 there. So now I have 3 nitrogen, 3 nitrogen. Well, guess what? We're done with everything but hydrogen and oxygen. So let's do the hydrogen. How many on this side? 3 times 4 is 12, plus 3 times 1 over here is 3, equals 15 hydrogens. Over here, I have in this 3 hydrogens. Over here, 3 times 4, 12 hydrogen. Wow, that equals 15 hydrogen. That's done. And the last thing to do is oxygen. And over here, 3 times 1, 3 oxygen. 3 times 1, 3 oxygen. And let's check, are we really done? 1 iron, 3 nitrogen, 3 nitrogen, 3 chlorine, 3 chlorine, 15 hydrogen, 15 hydrogen, and 3 oxygen, 3 oxygen, and we're done. And that's how you do it. Now, I'm going to do one for you, and this is called an even odd. And I have some on the practice problem set and also in the lab. Now, oops. That's better. On oops. Now, the question is, how do you balance this? And notice immediately we have 1 hydrogen here and 2 there. Immediately that tells me I'm dealing with an even odd. Now, if I tried, I could say I have 3 chlorine here. I put a 3 in there, but there's no way I can multiply this hydrogen H2 by a number to get 3 hydrogens. But if I were to look at this, if I double this, this would be 6. And now I could get that in there. So if I have 3, yeah. Three hydrogens, and over here, I have 6 hydrogen. Now I have 6 on this side and 6 on this side. Now this is probably tougher than anything I'd ever put on a test, but I just want to show you how tricky balanced chemical equations are. Now I can go back and finish this and say I have 6 chlorine. How do I get 6 chlorine? Put a 3 there. I have 6 chlorine. And now I have 3 aluminum. And if I put a 3 there, I have 3 aluminum. And let's see if we're balanced. 6 hydrogen, 6 hydrogen, 3 aluminum, 3 aluminum, and now 6. Did I do that right? Nope, I multiplied wrong. Even Dr. White makes a mistake. No, that's not. And that's why you do a double check at the very end to see if you messed up, which I just did. And let's unmess up here. Wrong one. Right one. For some reason, my eraser doesn't want to erase. That's weird. There we go. Let's do this again. All right, in order to get this to work, I have 6 hydrogen and 6 hydrogen. And where I made a mistake, somebody should have caught me, that should be 2. I now have my phone ringing. Well, I'm not going to answer it because it's not the White House. Well, I am in the White House. All right, one more ring. Thank you for stopping. Now I have 6 chlorine, 2 aluminum, and I have 2 aluminum. And now let's see if we're all good. 2 aluminum, 2 aluminum, 6 hydrogen, 6 hydrogen, 6 chlorine, 6 chlorine. And that's how you balance it. That's an even odd. Now, one of the things I've always shown you, and I do it when I'm balancing equations, is I do the accounting in the bottom, like balancing your checkbook, this and this. And that way you can find out if you made a mistake like I just did. Bad Dr. White, no. But anyways, ooh, that reminds me, my mother was an accountant, and when I got into, I was already working at a chemical company. One day we were talking, I was over at my parents' house, and she said, "Are you balancing your checkbook?" I said, "Yeah, but I'm off by a penny, so I don't care." "Oh, you got to balance it." I said, "I'm not going to spend an hour trying to find 1 penny. It's not worth my time." She was still upset with me because she was an accountant, and she just went, "You got to make sure you're right to the very penny." Nah, if I'm off by a penny, I'm not going to waste an hour of my time tracking it down. A lot of money, sure will, but 1 penny, no. All right, let's look at the lab you're going to do. And here are the various problems you'll do. And what you need to do is, and you can rewrite it over here because there might not be enough space for you to put a number in there. And you find out all these. Now, I won't do it on a test, but I think 1 or 2 of these are already balanced. But on a test, I would never do that. Thumbs up, people. Can you see problem set 1? Thank you. Now, notice I have a question down here that students forget the answer, so don't. That's what's the sum of the coefficients in the form, on the balanced form of equation 1. And that's, I believe, this one right here. Hold on, let me see if, yep, 1I. Looks like an I or J. Let's make it I. And therefore, this is the one you use. Now, let me remind you, And by the way, the second page has more stuff for you to balance too. And that's the lab. Let me remind you, when there's no number in front of a molecule or atom of a balanced chemical equation, the coefficient is 1. I'll say that again. When there's no number in front of an atom or a molecule in a balanced chemical equation, the coefficient is 1. With that, here's what I'm going to be doing. A couple of you I'm going to be inviting to breakout room. We'll spend about 10 minutes talking. The rest of you can go away. But if you have some questions, come back in about 10, 15 minutes, and I'll be still here at 10:45, and I'll answer any questions. So with that, except for a few of you, let me set it up right now. And I'd ask you to stick around, and I'll be doing this for all of us over the coming weeks. And I've just assigned people to breakout room 1. And you should have gotten a notice. The rest of you, I'll say, gang gesund, be healthy. I'll see you on Monday. For those of you in the breakout room assignment, let's go to our breakout room.